Usually when we talk about time in the business world, it feels incredibly rigid, like a physical law.
Right. Time has always been that ultimate unyielding constraint. You map out the sprints, you allocate the human hours, and, well, it just takes what it takes.
Exactly. You can't just fold a year of work into a week any more than you can fold a solid steel beam into a paper airplane.
Yeah, that's a great way to put it.
But then you look at what's happening right now in the technology sector, and suddenly that steel beam of time is completely malleable. I mean, we are looking at a landscape this week where a massive 231-day enterprise software migration was just folded down into 13 days.
It is honestly wild to even say out loud.
It really is. Welcome to the Friday, June 5, 2026 episode of the AI Loop. This is our weekly deep dive. Today we're tracking a very specific and frankly jarring theme across the industry. We're looking at the true cost and the true power of autonomy.
Because we are handing over the keys to these systems in ways we just haven't seen before.
Right. And the implications of that are echoing through software, medicine, global security, and even physical infrastructure. It's a lot to unpack.
It's the defining tension of the week, really. On one side, you have these autonomous agents compressing months of complex engineering into mere days.
Yeah.
But on the exact same timeline, you have major tech leaders looking at their infrastructure bills and realizing that paying for this level of artificial autonomy is, in some cases, actually costing more than hiring human beings.
Which is a crazy paradox. And our goal today is to cut through all that noise, summarize exactly what's happening, and keep you perfectly caught up on everything going on in the intelligence age.
Wow.
So we have to start with that first part, this monumental shift happening in software engineering.
The agentic shift.
Yeah. We have officially moved past AI as a fancy autocomplete tool. The era where you type half a line of code and hit tab to finish it. We're certainly in the era of autonomous, long-running agents now.
The paradigm has fundamentally shifted from, help me write this single function to go build this entire system, manage the environment, and just tell me when the project is done.
And the mechanics of how this is happening are fascinating. Anthropic just introduced something called dynamic workflows in their Claude Code platform. They added this new trigger word. If a developer types the word ultracode,
yeah.
Yeah, ultracode. Claude will dynamically write its own orchestration script on the fly. It doesn't just write code. It spins up a whole fleet of its own sub-agents to tackle different, complex tasks in parallel.
Which is a massive leap. And at the same time, Cursor just expanded its cloud agents, and they moved them to dedicated virtual machines running on Temporal.
Okay, we should pause on Temporal for a second, because that is the mechanism that makes this true autonomy possible, right?
Exactly. Temporal is basically an orchestration engine. In the past, if you had an AI agent running a task and the server it was hosted on lost connection or needed to reboot.
But what developers call a pod shutting down or hibernating.
Right, a pod. It's just a temporary digital workspace in the cloud. If the cloud provider needs to save resources, it shuts the pod down and your AI forgets everything. The task just died.
It had no persistent memory of what it was just doing.
Exactly. But by moving to Temporal, Cursor is giving these agents stateful durability.
And stateful durability, which means a permanent memory.
You got it. It means the agent can start compiling a massive block of code, realize it has to wait for a 48-hour automated security test to finish, willingly go to sleep, and then wake up 3 days later when the test results come back.
Wow.
It remembers exactly where it left off, and it just keeps working.
Which perfectly explains the staggering real-world impact we saw this week. Clement Delang highlighted a use case where Salesforce used Claude Code to ship a scoped software migration. Without AI, the project was mapped out to take 231 days.
And they did it in 13.
13 days. It was a single pull request that delivered 21 new software endpoints with 100% test coverage.
It's hard to overstate how disruptive that is.
And it wasn't just them. Wasmer's CEO, Cyrus Akbari-Nieto, noted they built a Node.js runtime for the edge using Codex.
Right, and to translate that out of developer speak, they built the foundational environment that allows code to run smoothly on small, remote devices rather than, centralized servers.
Yeah. Cyrus said building that foundational layer would have normally taken a year without AI. It took them 2 weeks.
The underlying mechanism here is the decoupling of human typing speed from engineering output.
Huh. That's a good way to frame it.
Yeah, the bottleneck is no longer how fast a human can write and test code. The new bottleneck is simply how effectively a human can define the final objective for these systems.
But, I mean, if I'm an engineering manager, I'm looking at this and I'm getting incredibly nervous.
Oh, for sure.
If an AI is churning out code at 50 times the speed of a human, and it's allowed to spin up its own subcontractor agents to do it, aren't we just, automating the creation of disastrous buggy code? I mean, how on earth did Salesforce see their total bug incidents actually drop by 5%?
That is the exact fear that kept companies from adopting this earlier. But it's also why Anthropic built a mechanism called adversarial verification directly into these dynamic workflows.
Adversarial verification.
Yeah. When you type ultracode and Claude spins up its subagents, it doesn't just spawn a bunch of coders. It intentionally spins up separate subagents whose sole job is to be aggressive skeptics.
Oh, so it's essentially acting like a digital courtroom.
Right.
It plays both the defense attorney building the case and the prosecutor trying to tear it apart.
That's a perfect way to visualize it. The skeptical agents review the code generated by the builder agents, and they actively try to break it against a strict grading rubric.
And if it breaks?
If the code fails, the builder agent has to rewrite it. They resolve their own disagreements based on the logic of the code itself.
Wow.
So quality isn't being sacrificed for speed. The quality assurance standards are baked directly into the autonomous loop. The AI thoroughly audits its own work before a human ever even looks at the final product.
Which is just an incredible leap in reasoning. But let's take that exact mechanism, an AI agent that can autonomously reason through a complex architecture, test its own logic, and find hidden flaws, and look at what happens when you point that exact same capability at biological architecture.
Right, the shift to vertical AI.
Exactly. Because this week, we saw frontier models being specialized for high-stakes, incredibly complex vertical domains, specifically biology and medicine.
We are crossing into a completely new frontier of clinical discovery here.
Yeah.
The major labs realized that, a general-purpose model is great for writing emails or basic code. But to push science forward, you need models post-trained exclusively on the laws of physics, chemistry, and biology.
And OpenAI just proved how powerful that can be. They released GPT-Roslyn. It's a model purpose-built entirely for the life sciences.
Right.
They tested it on the Life Sci Bench evaluation framework, and it actually outperformed their flagship GPT 5.5 model. It is insanely good at extracting and auditing scientific evidence.
And the real-world example of this is just wild.
Yeah. For example, researchers had it review a submission package meant for the FDA regarding a treatment for a rare muscle disease. And GPT-Roslyn flagged that a specific chemical test, a microdystrophin assay, was actually flawed.
We should really break down exactly what the AI caught there, because it highlights the depth of its reasoning.
Right. So to put this in plain English, the researchers were trying to prove their new gene therapy was producing a specific muscle protein. The AI looked at the raw chemical data and pointed out that the lab test they used couldn't actually tell the difference between the patient's natural existing muscle protein and the newly introduced synthetic protein from the drug.
It caught a microscopic chemical nuance that could have derailed a multi-million-dollar clinical trial.
Exactly. And that level of precision isn't just theoretical anymore. Boston Children's Hospital just revealed the results of an enterprise AI layer they deployed across their entire clinical network.
The scale of what they did is amazing.
Yeah, their chief innovation officer, John Brownstein, explained that they built a custom co-pilot geneticist. This AI autonomously synthesized fragmented genetic data from patients and then cross-referenced it with decades of global medical literature.
Which is something no single human could ever do.
Right. And it successfully diagnosed more than 40 rare conditions that human doctors had previously considered impossible to solve. On top of that, the hospital used operational AI to save 60,000 hours and $7 million in redeployed labor.
Which forces a really uncomfortable but fascinating deduction.
Yeah.
If an AI is successfully diagnosing rare diseases that stumped the absolute best human specialists in the world, it isn't just because the AI is a fast reader.
Right.
It's because the AI is capable of holding millions of variables in its active working memory. That is a feat that is biologically impossible for a human brain.
Right, because the human mind, no matter how brilliant, has cognitive limits.
Right.
I mean, a doctor cannot hold millions of pages of global medical literature, recent clinical trial data, and thousands of fragmented genomic sequences in their working memory, all at the exact same moment.
Exactly. The AI can. And more importantly, it synthesizes across entirely different scientific modalities.
What do you mean by that?
Well, it can look at a chemical molecule, a mutated gene, and a biological pathway simultaneously to surface the hidden connections that humans simply miss, because we cannot zoom out that far while retaining all the microscopic details.
It holds the entire biological puzzle in its head at once.
Precisely.
But, that transitions us to the darker side of this autonomy. Because if an agent has the autonomous reasoning to navigate the complex pathways of a hospital's database to find a cure...
That exact same autonomous reasoning can be weaponized.
Exactly. It can be weaponized to navigate the complex pathways of a secure corporate network to find a vulnerability.
And cyber threat actors are actively weaponizing these exact same autonomous capabilities. It is forcing a complete ground-up rethink of global cybersecurity frameworks.
We saw a stark warning about this. Anthropic released a massive report analyzing 832 malicious accounts on their platform. And they mapped the activity of these hackers to the Anime ATT&CK framework.
And for context, NMR ATT&CK is essentially the global, standardized playbook that cybersecurity professionals use to classify the exact tactics and techniques that hackers use.
Right. And Anthropic found that attackers are shifting their use of AI much deeper into the attack lifecycle.
The specific data points here tell a very clear story. Anthropic noted that AI-assisted phishing actually fell by 8.6%, but using AI for lateral movement and account discovery inside compromised networks is rising sharply.
And let's clarify that difference, because it is the core of the threat here. Phishing is just tricking someone into clicking a bad link in an email. It's like breaking a window to get into the lobby of a building. But lateral movement, that means the hacker is already inside the lobby. And now they are creeping through the air ducts, stealing employee key cards and trying to find the master vault, all while actively avoiding the security guards.
Yeah.
Giving an AI the autonomy to make real-time, split-second decisions to navigate a secure network like that is a massive escalation.
Because it requires situational awareness. A phishing email is static. Lateral movement requires the AI to look at a firewall, realize it can't get through, and autonomously decide to try a different server port instead.
Which is why OpenAI is moving aggressively on the defense side right now. They just published a blueprint for democratic governance of frontier AI. They are officially backing strict state laws like California's SB 53, and they are calling for a federal framework under the Center for AI Standards and Innovation.
CAISI. Right.
CAISI. They're also expanding Project Glasswing to 150 more organizations. That project grants trusted network defenders early access to their Claude Mythos preview model. They're basically giving the good guys the strongest AI to patch vulnerabilities before the bad guys' AI can find them.
But the real challenge for those defenders is how the nature of the threat itself has mutated.
Yeah, and there was a specific detail from the Anthropic report that proves this. They found that the least skilled hackers use an average of 16 different MI techniques, and the most skilled, most dangerous state-sponsored hackers used about 20.
So the raw number of techniques a hacker uses doesn't define how dangerous they are anymore.
Right. So if it's not the techniques, what actually separates a nuisance hacker from a catastrophic threat?
The differentiator is the architecture. It's the scaffolding the attackers build around the AI model.
The scaffolding.
Yeah. The code itself isn't the primary weapon anymore. The weapon is the custom environment that allows the AI to chain together discrete, complex stages of an attack with almost zero human input.
Wow.
They set the final objective, like, extract the customer database, and the agent orchestrates the entire multi-day operation. And here's the terrifying part.
What's that?
The MIT or ATT&CK framework we just talked about, it doesn't even have identification codes for agentic orchestration yet.
You're kidding.
No. The global framework we use to track threats literally lacks the vocabulary to describe what AI agents are currently doing. Defense strategies have to adapt immediately.
That is wild. But, to defend against those autonomous threats, or to power the agents curing those diseases, or to run the dynamic workflows folding software development into 13 days, all of that requires an incomprehensible amount of physical electricity.
It really does.
The cost of artificial autonomy is measured in physical gigawatts now, which brings us to the massive industrial scaling we saw this week.
You cannot have exponential software growth without exponential physical infrastructure. The capability leaps we're talking about require equivalent leaps in concrete, copper wire, and energy supply chains.
And to put that physical reality into perspective, OpenAI just broke ground on a facility they're calling the Barn.
The Barn?
Yeah, it's a massive 1 gigawatt data center campus in Saline, Michigan, built in partnership with Oracle and Walbridge. It's expected to create 2,500 union construction jobs.
That is a massive project.
It is. They made a point to guarantee that the massive infrastructure costs will not be passed down to local residential ratepayers, and they implemented a closed-loop cooling system that only uses as much water as a typical office building.
Which is crucial for community buy-in.
Exactly. Plus, to ensure broader access to the technology this facility will power, OpenAI is providing up to $45 million in Codex credits to eligible Michigan college and trade school students, keeping this tech within reach of the next generation.
That's a huge investment.
Yeah. And on a corporate side, OpenAI models and Codex are now generally available on AWS Bedrock.
Which is a crucial integration. AWS Bedrock allows massive enterprise companies to deploy these OpenAI tools through their existing, highly secure procurement workflows.
It basically solves the corporate red tape.
Right.
But I want to go back to the physical red tape for a second. A 1 gigawatt data center.
Right.
I mean, the gigawatt is roughly the power output of an entire nuclear reactor.
It's staggering.
It reminds me of how aluminum smelting plants are built. Aluminum production requires so much raw electricity that they literally have to build the smelting plants directly next to hydroelectric dams.
Yeah, it's essentially solid-state electricity.
Exactly. That's what these data centers are becoming, facilities where the primary raw material isn't code, it's sheer megawatts being forged into intelligence. But why is a software company like OpenAI directly involved in pouring concrete and managing local water usage in Michigan?
Because compute is the ultimate strategic advantage right now. Having the best algorithmic theory is no longer enough to stay ahead. The limiting factor for AI progress is physical reality.
Right.
If you don't control the concrete, the server racks, and the direct connections to the power grid, you don't control your own destiny. Bringing models to AWS Bedrock to solve enterprise software friction and building gigawatt data centers to solve physical friction, they are two sides of the exact same strategy.
Making intelligence cheaper, more reliable, and securely available at an industrial scale. But does every single automated task actually require a 1 gigawatt nuclear scale brain?
Well, that is the million-dollar question.
Right, and that question is forcing the market to adapt. It's fueling a massive contrast in the AI ecosystem. While these massive companies are pouring concrete for gigawatt data centers to run frontier models, there is a quiet, aggressive revolution happening on the edge with incredibly small, highly capable open source models.
We are seeing a hard divergence between centralized, massive intelligence and decentralized, highly specialized, local intelligence.
And Google just proved how capable local intelligence has become. They released Gemma 412b. This is a unified, encoder-free, multimodal model.
And to break that down, multimodal just means it can natively understand text, images, and audio without needing clunky translation layers in between.
Right. And the best part, it runs entirely locally on a standard laptop with just 16 gigabytes of VRAM, which is just the memory on a standard professional graphics card.
So you don't even need a cloud connection to run it.
Exactly. You don't need a cloud connection. It's released under an Apache 2.0 license, keeping it open and within reach of developers everywhere. And the market is absolutely responding to this.
Oh, massively.
Voices in the space, like Bindu Reddy, pointed out that open source AI growth has exploded by 500% in just 2 months, driven by hyper-efficient models like DeepSeek Flash and Kimi 2.6.
And we are seeing companies use these smaller models to fundamentally alter the economics of AI.
Exactly. Harvey, which is a legal AI company, just tested a hybrid setup that perfectly illustrates this. They used the open-source GLM 5.1 model as their primary worker model, and they only routed tasks to the incredibly expensive, massive Opus 4.7 Frontier model to act as a reviewer.
The mechanism of how they route those tasks is the real secret to making this work. They use a smaller, cheaper model as a dispatcher.
Right. So it looks at the user's prompt. If the prompt is just asking to reformat a standard legal document, the dispatcher sends it to the open source model. It's like handing the paperwork to an army of brilliant interns who work for free.
That's a great analogy.
But if the prompt requires a complex, multi-layered legal argument, the dispatcher routes it to Opus 4.7, the equivalent of bringing in the $1,000 an hour senior partner.
And the results of that hybrid approach are incredible.
Yeah, this hybrid setup actually beat using the expensive Frontier model alone on quality. They saw an 18% pass rate versus a 14% pass rate.
Wow.
And the cost savings were radical. The task cost $368 using the hybrid setup, compared to $954 if they just used the massive model for everything.
This really proves that the era of relying on one massive frontier model for absolutely everything is ending. Routing tasks to open source models that are post-trained for specific verticals gives developers privacy, speed, and just massive cost reductions.
So the frontier models aren't obsolete. They are just shifting from being the sole laborers to becoming the senior orchestrators,
Exactly.
which perfectly sets up the ultimate cost of autonomy. And it brings us to our take of the week.
This is a fun one.
Yeah. We've talked about agents saving time and open source models saving money. But there is a provocative, intensely debated question circulating right now. Does AI actually cost more than human labor?
It's a jarring question, especially after we just detailed 231-day migrations happening in 13 days.
Right.
But the economics of scaling AI are hitting a wall of physical and financial reality.
Bindu Reddy really sparked this debate online. She pointed out that frontier labs are driving API costs through the roof. Enterprise companies are running up $100 million bills, getting massive sticker shock, and in some cases, they are capping their AI usage and actually laying people off.
Because they look at the balance sheet and realize that globalized human labor, like hiring an offshore engineering team, is actually cheaper than burning tokens on a massive frontier model.
Yeah. Matt Schumer noted that a single OpenAI power user is currently burning 100 billion tokens a month. 100 billion.
And we saw a massive market signal in response to this anxiety over return on investment. Cognition, the company behind the Devon AI software engineer, launched an unprecedented $10 million AI productivity guarantee.
They are literally promising to fund a customer's usage if their AI doesn't deliver the exact measurable engineering value the customer is paying for.
Yeah.
I mean, why would they take on that kind of financial risk?
Because they know that enterprise companies are demanding hard ROI now. The honeymoon phase of buying AI for the sake of AI is completely over.
Right.
The compute required to generate and answer the cost of inference is incredibly high. If an autonomous agent goes down a rabbit hole, gets confused, and burns millions of tokens on a dead-end approach, that isn't just a failed task. That is real, tangible money evaporating from the budget.
It is such a stark contrast. On one hand, you fold months of work into days, saving immense capital. But on the other hand, if you don't build the right scaffolding, a single badly optimized autonomous loop can cost you more than outsourcing the task to humans. If you are just maximizing tokens by throwing the biggest, most expensive model at every trivial problem, you aren't maximizing productive output. The businesses that actually survive this era will be the ones that master that hybrid approach, running the free open source interns on the edge for the routine work, and reserving the massive gigawatt-powered frontier models for the high-value orchestration.
It really forces every listener to look at their own workflows. Are you deploying intelligence efficiently, or are you just burning compute?
That's the question. All right, let's do a rapid recap of the deep dive. This week, we watched autonomous agents orchestrate massive software migrations by testing their own logic. We saw GPT Rosalind hold millions of biological variables in memory to solve impossible medical mysteries.
We tracked how hackers are using agentic scaffolding to navigate corporate networks.
We explored the 1 gigawatt physical footprint required to run these models. And we watched open source hybrid routers challenge the fundamental economics of expensive frontier AI.
The technology has truly crossed the threshold of autonomy, but the physical and financial constraints of reality are pulling back.
They really are. And I'm going to leave you with a final thought to mull over. We started today talking about folding time and how a year-long project can suddenly be collapsed into days. But if an AI company now feels the immense market pressure to offer a $10 million guarantee just to prove to executives that their software is actually more cost-effective than a human employee, what does that reveal about the true, lasting premium of human ingenuity?
That's a great point.
Maybe the human mind and our ability to intuitively orchestrate these tools is the one resource in the intelligence age that truly cannot be replaced or folded away. Thanks for joining us for this episode. Be sure to tune in next week to catch up on everything happening right here in the AI Loop.